So here we have the graph of leaf litter bag decomposition that we created earlier. We have a bar graph that shows what the average percent mass loss was for each leaf litter type, as you can see within these three bars. And the mean for one treatment, the water saver here, seems to be overall higher than the other two. So we think that overall, this type of leaf litter decomposes faster. But as you can see back in the spreadsheet of the data, there are also lots of data points high and low for each different type of leaf litter bag type. So how can we know for sure that the average that we have on this graph here is a real difference that it shows, or is it something that might be higher or lower just due to chance? So one of the ways that we can do something to help us determine whether it is due to chance or whether it is statistically significant is by adding standard deviations onto our graph. So our standard deviation is just going to show us whether there is much overlap between the data points that we have within each three of the treatments. So to do a standard deviation graph, we're going to follow some of the same steps as before. So I'm going to make this graph a little bit smaller, and on the right hand side here, I'm going to create a new table. So I'm going to write standard deviation. And just like before, I'm going to use the same three categories. So we're going to make another equation. So this time we're going to write equals stdev for standard deviation, open that parentheses, and then again we're going to highlight all of the data points for water saver, all of the data points for water spender, and all of the data points for non-native plants. So I can go ahead and highlight these points and close that parentheses, and I will repeat. So then the water spenders, and then again the non-native plants, and highlight all of those points as well. And now we have a standard deviation for each one of those leaf litter bag types. I'm going to go ahead and make my graph a little bit bigger again. Next, we're going to want to add these standard deviations onto our graph so we can see what they look like. Because each one of these leaf litter bag types has a different standard deviation, we're going to have to add them manually to each one. So what we can do is we can click on the three dots here on our graph, and we're going to click on Edit Chart. This is going to bring up our chart editor again, and just like before, we're going to make some adjustments to the graph. So first, I'm going to start by clicking on Customize, and then I'm going to click on Series. When I'm under Series, I'm going to make sure that I am applying one graph at a time. So under Apply to All Series, I'm going to go ahead and click for each individual one. So let's start with Water Saver. So I'll go ahead and click on Water Saver. And to add a standard deviation, we're going to essentially add what Google Sheets considers an error bar. So I'll go ahead and click on this checkbox for an error bar. The next thing I need to do is go over to percent, and instead of percent, we're going to write in the constant. We are not going to use the standard deviation that it has here, or Google Sheets will try to create one automatically that was shared between all of them. So I'm going to go ahead and write in constant, and I'm going to take the standard deviation value that we measured. Right now it's currently set to 10, but as I can see here, our water saver has a standard deviation of 2.1534. I'm going to write a few numbers in. Next, I'm going to go back, and under series again, we're going to go to water spender and add in the standard deviation to our water spenders. So just like before, we click on error bars, click on constant, and add in our new value. So 0.7715. And then lastly, we have one more graph, our non-native plants. We'll click on error bars, constant, and we'll change the value to 4.891. And you'll notice that I forgot a decimal there, so I got to make sure to go back, or else it doesn't show an accurate graph of what with those standard deviations. So once those are all done, I can go ahead and exit from there. And I'll pull my graph here so we can see it a little bit better. So how do we know what the standard deviation that we have just put into this graph means? Well, if all of our measurements were close together and the standard deviation is small, you'll notice that there is not a lot of random variation between the data points that we collected. Therefore, you'll also notice that the standard deviation lines don't overlap a lot, and that most likely our results are showing a real difference between the different treatments that we have here on our graph. If the measurements were really spread out, as we saw in some of our data here, you'll notice that our standard deviation will be large, as you see in our water saver, and means that there's a potential for a lot of overlap in our standard deviation from one leaf litter bag type to another. That means that there is a chance that our data didn't have significant trends and that there may be too many random differences to say for sure if our results are real. For our results to be considered statistically significant, we don't want these bars to overlap at all, because if they overlap, the real value could be on the lower end of this range, or it could even be on the higher end of this range. And as you can see, with something with such a large standard deviation, that is a pretty big range for your average percent mass loss. So we want to make sure that we can add standard deviation to our graphs. So go ahead and add standard deviation into your other two graphs for soil moisture and for the restoration effect on decomposition and see what that looks like. Once you have done that, you can see if your results were significant or not.